Hello and welcome to the section on time series analysis of wind speed data, where we'll proceed our series of practical examples of data analysis. In the previous section we explored the use of clustering algorithms. In this section we'll dig into time series analysis. In this video we'll learn some theoretical concepts that you need to complete for this exercise. In particular, we'll understand what can be defined as time series, and what is the purpose of a time series analysis. Then we'll look at time series decomposition and correlation, and finally we'll look at various forecasting techniques. Let's start our discussion by explaining what do we mean when we talk about time series. That's easy. For time series, we intend data that have been measured at constant time intervals. The main characteristic of these data is that they all present some form of time-wise variations. For example, this time series shows the time variation of ozone data collected in a measuring station in the US. From this plot, it's easy to see that the ozone values change over time in a way that may appear totally random. However, most time series present variations that can be explained somehow. Finding explanations for the variation in time of the variable of interest is the very first purpose of a time series analysis. This is another example of time series showing bicycle accidents. This plot shows the decomposition of the time series signal. The first plot on top shows the measured data. As you can see, it's clear that during summer months the number of accidents increases. When we see this sort of repeating pattern in a time series, we talk about seasonal variation. Another important aspect that needs to be investigated in time series is trend. This is a systematic change that is not periodic. For example, if during the study period the number of accidents decreases linearly, this is a decreasing trend in our data. Finally, as for every environmental data, time series are affected by a certain amount of random variation that cannot be explained either by looking at the overall or the seasonal variability. This is referred as the random variation. Another crucial concept related to time variability is autocorrelation, meaning the correlation between data collected at certain time distances. For example, if we determine that our data have a seasonal variation, we may see that data collected at intervals of 6 months are more correlated compared to data separated by shorter time intervals. This is autocorrelation. All these concepts allow us to proceed to the next and probably most important phase of time series analyses, which is forecasting. In simple terms, forecasting implies predicting the future. In other words, we can assume that the time variation we are observing in our data will continue in the future. And this implies that we can use our time series to estimate what will be the temporal pattern of our variable at future intervals. There are many ways to forecast a time series, and in this section we're going to explore some basic ways, like the one you see in this image taken from the book entitled Forecasting, Principles and Practice. Probably the most basic method is the mean method, where all future values are assumed to be equal to the mean of the time series. Then we're going to look at the naive method, where all future observations are set equal to the last recorded value in the time series. A more complex method is the seasonal naive, which sets the value of future events equal to the average value for the same time interval in the data. For example, the average value in the month of August will be used to estimate all future Augusts. More complex methods involve the estimation of both trend and seasonal variation in the time series. A commonly used technique is the ARIMA model, which stands for Autoregressive Integrated Moving Average. This method may reach better predictive results, and in this section we're going to see how to apply it. You can find more information on time series analysis by looking at these resources. In this video we looked at some theoretical aspects we need for time series analysis,